Hello, everyone. Welcome to Listening to the Wind, the regular IWSA interview series. And today I'm sitting here with Wilf Chaplin. Hi, Wilf.
Hi.
Hi, good to see you. And Wilf is a sail designer with OneSails, a leading sail producer based in Hamble near Southampton in the UK. Wilf's entire career has been moving vessels around the sea by the power of the wind. And today that means mainly yachts, but in the future, more and more commercial ships. Wilf joined OneSails 12 years ago after working in an independent sail off. So a huge amount of experience. Wilf, really looking forward to this presentation and chat afterwards.
Yep, I'm looking forward to having a chat and
absolutely
talking about moving stuff around the sea.
Talking about wind, talking about ships, absolutely. Yep. So I'm going to hand it over to you if you would like to share your screen, and then I'll come back in about 10 minutes for our discussion.
Yep, okay, lovely. It'll be just a short presentation, but just describing OneSails and what we do. So, as Gavin said, I work for OneSails, and we work very closely with Flexon Composites. OneSails have been at the forefront of the market for yacht sails since their formation. The leisure sector is the current core of this market, but we firmly believe there's a massive potential for technology transfer from the active leisure market to the nascent commercial market. When we say yacht sails, people often think of the small boat they see sailing around the bay. These days, yacht sails are several hundred square meters, propelling vessels of 40, 50, 60 meters and more around the ocean. These are comparable to the sails that will be needed in some of the smaller commercial vessels. So we already have the technology to build and produce robust sails of this size. OneSails have exclusive access to the products of the Flexon Composites, which are used as the basis for the largest and most highly loaded sails we build. For the commercial sail market, Flexon will complete the manufacturing process and produce the whole sail in an ISO 14001 certified manufacturing facility in Italy. Many groups have market-ready plans for both new build vessels and retrofit installations. These plans involve sails with several hundred square meters with corner loads of 30 tons and more. Flexon Composites are uniquely positioned to supply the membranes needed to produce the sails to power these vessels. Looking further forward, Flexon have the technology to produce materials suitable for the surfaces of the many wing sail systems in development, offering better UV resistance and other flexible options, and a better combination of weight, strength, and robustness than rigid options. Flexon Composites and OneSails can be contacted here.
Okay, thanks, Wilf. That's a short but sweet presentation. And I've got a few questions about that. That's great. So you were talking about that size of sail, that picture of the guy standing with right by that corner.
Yes.
just really does emphasize the size and the scale of the sails you're talking about.
Yes.
Well, what is the largest installation that OneSails has actually done up to now?
The largest single sail we've done, I think, is 340 square. Well, the 4.5 sail is 340 square meters. For downwind sails for yachts, we've done 800 square meter sails. But that's slightly different in that they're not the sort that would transfer to most shipping projects, because they're very light. If it's not fragile is the wrong word for it. They need quite a lot of manpower to control and handle them. They're not something that could be used on a furling system as a push button system, if you like. They require crew involvement.
So that commercialization, the sort of automation, as you say, automatic furling systems or whatever. Does that actually change the materials that you would be using, or the production or manufacturing processes?
Well, Yes and no. In general, all sails at this sort of size on yachts are already handled by furling systems. So
Right.
it's very rare that you'll see a 300 square meter sail that doesn't have a handling system of that type already. So we're already familiar with building this sort of sails for this sort of system, and the systems are available not exactly off the shelf because they're custom products, but they are. You can go and order one. It's not something that needs developing. It's just something that needs ordering. So the technology is there and active in the leisure industry. It just needs applying to slightly less shiny vessels.
Yeah, no, absolutely. And I think, you mentioned about sort of technology transfer, a kind of, when we were talking earlier, you were saying, that to me, there's a huge amount of knowledge in the racing and yachting world around wind that we're starting to see coming into the commercial wind assist and wind market.
Some of the America's Cup campaigns, if you think BAR are involved now, if you look around, there are a spattering around the industry who are noticing the potential. That they've got this, as you say, they've got this huge knowledge base, which they've always focused on a particular area because that's what they've acquired it because they were interested in racing or what have you, and they haven't up until now realised what they're sitting on. This trove of knowledge, which it's great. They see this lovely little market which they are pursuing and developing, not realizing there's this huge, vastly bigger market which could apply the technology they have, but they just haven't, in general, up until now, made the link.
No, indeed, and I've actually talked with some weather routing guys that were doing the weather routing for America's Cup and a few others.
The Vendée Globe people, I guess, would be.
Yeah, and they're saying like the points of data that they've got is like every second.
Yes.
Which is probably a little too much for a little bit too granular for commercial applications, but an incredible amount of data, incredible amount of knowledge. And I was just wondering, if I was to come to OneSail, I'm going to put you on the spot here. If I was to come to OneSail and say, look, I've got a vessel, maybe an 80-90 meter commercial vessel, with a standard rig design. I mean, how long does that actually take to fabricate? You mentioned that pretty much the materials are there. They are obviously designed for each vessel.
Yeah.
But how long does that manufacturing process really take?
The manufacturing process for something like that could be, it would be in sort of, the actual physical process would be in weeks or months at the most. Right. The biggest point would actually be managing to make sure that there is factory capacity to do it, because we're running, with our current market, we are running pretty much at capacity. But the actual physical process of building one could slot into our it could slot into our backlog, and it would just be something we could produce starting tomorrow.
Right. But it's weeks. It's not months and months. It's weeks, potentially a couple of months.
Yes. Having said that, at the moment, our order book is full. That when people are phoning up now, delivery for their yacht sales is in June.
Well, that's a nice problem. That's a nice problem.
Oh, it's a nice problem to have. But yes, no. But it's not that. It's not that we need to develop new things to do it. We can do it. It's just we need, we just need the orders to produce, if you like.
So it's that lead time, and again a nice problem if you have to set up another manufacturing line. If the demand's there.
The site in Italy has been chosen and developed in such a way that there is actually space to expand it. It's,
right. Excellent. Well, hopefully that demand will be growing quite soon.
Well, indeed.
And then on a couple of questions on the materials. Obviously, the life cycle analysis is a very big thing and a growing thing in industry now. So could you walk me through, the materials and, are these able to be recycled? Are they
the essential material, that the core material that we use in our products is ultra high molecular weight polyethylene, which is recyclable. It can go into the same recycling stream that your milk bottles go into. So the material we use is actually virgin material rather than recycled going into the process, because the demands on it are really quite extreme. If you're looking at the corner loads in some of the sales will be 30 tons or more, and you then need to be able to transfer that load out into membranes that are less than a millimeter thick. So it's a fairly demanding field in which they're working, but they are recyclable at the end of their life. Also, compared to many of the other, if you think of your conventional yacht sails that you see on the 30 or 40 footer sailing around, they're very often made out of woven polyester. And then on the higher range racing yachts, you'll see the use of carbon fiber and things. Compared to both those products, the ultra high molecular weight polyethylene has, well, compared to carbon, for example, it has 1/12 of the embodied energy of a carbon sail.
Wow.
It's about 50% of the embodied energy of a polyester sail, because the temperatures at which it's processed are significantly lower than either of those products.
Right.
Also, we avoid the use of adhesives and what have you in the manufacture of the products, because the membranes are up to 18 or 20 layers thick. Even though they're only 1 millimeter thick, there are 18 or 20 different layers that go up to make that millimeter.
That's incredible. That's incredible.
Yeah, it's not a simple process. But all of those layers are subtly different forms of the UHM WPE, so they can all be recycled together. You haven't got the problem of mixing different materials that need separating out before you can recycle it.
Gotcha.
And because we avoid the use of solvents and adhesives, that avoids many of the environmental problems associated with the volatile VOCs, which are associated with them.
So that's really that material science has really come on.
Oh yes, no, it's come on a long way. And as I say, the sails are, the membranes are 14040 LCA certified. The plant that they're made in has a ISO 14001 certification. It has from the very start been built as a sort of sustainable way of building sails.
Right. Yeah. Excellent. Now I think that is a very important element, especially for the commercial companies now coming in with restrictions on the amount of carbon, and, as you say, embodied carbon, but also looking to that circular economy issues as well.
And it is only a small part of it. We earlier last year or 2 years ago, we did a study looking at the embodied energy of a wind ship, because, to be honest, we were looking at, to a certain extent, doing it as a commercial proposition. We were hoping to demonstrate that by using our sails over somebody else's sails, you significantly improved the performance of your vessel from its environmental perspective. What we did actually find is that actually your choice of mast material is more important than your choice of sail material, because even though the sails are, they have a limited lifespan, so they will be replaced several times in the life of the vessel, because the mass of them is so small compared to the mass of the other things in the vessel, the embodied energy in them is actually quite small. But the embodied energy, for example, if you choose a steel mast over an aluminium mast, that made a way more significant difference, just because of the total mass of the material involved.
Gotcha. Yeah.
It was quite interesting, wasn't it? It's slightly disappointing that it didn't provide the.
It didn't provide as much of a driver as it would.
No.
Yeah, but it is a driver.
Yes,
it's driving the ship. So.
Oh, indeed, yes.
You mentioned about durability, and obviously UV is a significant issue around the use of soft sail. What is the performance like for the sails that you're producing?
It's got very, very good UV resistance. It's not completely immune to it, in that it just does slowly change over time, but it's not a defining factor in the life of the sail. If you look at a polyester sail, the outer surface of the polyester sail loses its strength really quite rapidly.
Right.
With exposure to UV light. The UHWP, the ultra high molecular weight polyethylene really is virtually unaffected by it. It carries on.
Oh, that's excellent.
Yeah,
that's excellent.
It is one of the reasons it was chosen.
Yeah, and we were talking about, or you were talking about the size of vessels. And obviously, especially at that sort of smaller end, maybe 100 meter, 120 meter vessels, which we're seeing designs coming through for those now, for primary wind vessels. How do you see? Do you see that as being the sort of the market end, or the big growth market area for wind ships? Or do you see larger vessels?
I think all of them have a part to play. I think short sea shipping, especially in Europe, is underutilized. Is my perception of it. If you look around the coast of the UK, for example, there are, how many it is now? There are, I think it's over 900 ports, or places that have historically been ports that could accommodate small vessels. We're talking 30, 40 meter vessels. But if you look at the number that are actually working at commercial ports now, you can virtually count them on the fingers of one hand. So there's a significant infrastructure resource there that's not being utilized by shipping at the moment, which I think could be. Which small vessels are, they're small ports. Small vessels are ideally suited to them, and they're ideally suited to wind.
Yeah, I think that that obviously, as we know, there are a number of smaller vessel operations going on, and from the cargo owners that I've talked to, that kind of point-to-point movement of their goods is really important to them, because it's like in a sense, it's like the final mile. Use. So once you've got the ship into a large port, if it's a large ship, containers, yes, that was very cheap, but then now you've got to truck it halfway across the country to get to the final point.
We're, at one point, I was doing some work looking at container movement costs, and it was cheaper to get at that time. It's obviously changed slightly because we know what's happened to container rates. But 2 or 3 years ago, it was cheaper to get a container from China to Southampton than it was to get the container from the deck of the ship onto a lorry. So it's sort of
it's I think that whole logistics chain is a really interesting sort of adaptation. I mean, obviously it takes quite a long time to develop a network, but you see smaller vessels operating more on point-to-point.
I think that would be a very good thing to develop. One of the big things that acts as a block to short sea shipping, I think, is the intermodal costs, because the intermodal cost, it doesn't really change whether you're moving once it's on the ship, whether it's moving 100 miles or 1,000 miles. The cost of getting it onto the ship and off the ship is the same. So when you can have facilities directly, next to the port, so it goes straight into the destination rather than onto somewhere else, that really pays dividends, and that works better with smaller vessels, because you can then have smaller ports, and there are the ports around which are just underutilized for that sort of thing.
No, that's very true, and I think you're absolutely right. In the UK, that is particularly noticeable, I think.
Yes. Yeah.
If you go to sort of Dutch ports, or other North Sea regions, I think they utilize their resources a little better than we do in the UK. Yes. But the just taking that maybe to another state. Obviously there are regions in the world, outside of Europe, that have very long distances. I'm thinking sort of South Pacific, inter-island trading, some in the Indian Ocean as well. Are those markets that you've looked at, or are those potentially growth markets in the future for small vessel operation?
They're undoubtedly ideally suited for small vessel operation. It would make more sense for them to manufacture. There's no point in manufacturing ships and sails here and moving them to the Pacific to do the work. So it would be. OneSails is actually an international group. We have lofts, literally all around the world. So it would be very sensible for local manufacturer to produce sails and ships for that market. There is, I agree.
Yeah, no, yes, absolutely. And I know a project that you were involved with, or some research that you were involved with, was around autonomous vessels. Quite small scale wind, looking at wind and autonomous operations. Can you tell us a little bit more about that?
Yeah, so I was just interested to look at I was essentially trying to look at the blocks to why there seemed to be so much resistance to wind power in shipping. This is 10 years or so back. And when you look at the cost drivers for shipping, there are essentially three of them. The biggest one's the capital cost. You then have the fuel costs, and you have the crew costs. As you move towards smaller vessels, which are from our perspective, we know easily we can move 60, 80, 100 meter vessels around using the technology we've got. When you look at why people are using bigger vessels, it's because the capital cost gets greater per ton kilometer as the vessel gets smaller. So I was just looking to see whether by using wind power, you obviously reduce significantly the fuel costs. So that's one of your costs going down, but that wasn't sufficient on its own to balance the increased capital cost at the time. So I was just contemplating looking at reducing the crewing costs as well by the adoption of autonomy, which sort of seemed to work very well with as a concept with smaller vessels. So sort of by reducing the vessel size and then introducing autonomy, you actually reduce the capital cost of that vessel for its given size, because you're no longer having to provide the space and accommodation and what have you for the crew, and it turns into a sort of virtuous small circle in that a smaller vessel again works better because you have sort of removed one of the blocks to making that smaller vessel work, which then gives you access to smaller ports, and it sort of seemed to work as a way of building access.
No, interesting. Yeah. And were you looking at fully autonomous sail vessels, or were you looking at highly automated? It
was a sort of study of a concept, if you like. So I was actually looking at fully automated vessels, because there's nothing. There's nothing to stop a fully automated vessel working. If you look in Norway, they have autonomous vessels moving.
Indeed.
Sail handling systems, by the time you get to vessels of this size, they're not manual anyway. They're working at the press of a button. So whether it's a relay pressing that button or a human pressing that button is essentially irrelevant. It is, going back 10 years or so, whenever it was I was doing this, I went to various wind power focused conferences and what have you. I went to various autonomy power focused conferences. And whenever I was at the wind conferences and started talking about autonomy, people sort of looked at me slightly strangely and sidled away. Whenever I was at the autonomy focused conferences and mentioned wind power, people looked at me slightly strangely and sidled away. Whereas now both fields actually people are looking at seriously and realise that actually that's part of the future.
There certainly is some convergence there. Yeah, I mean, as you mentioned, most large vessels are highly automated anyway,
Yes.
not autonomous, but highly automated.
Indeed,
So,
yes. Yeah.
So we're already on that pathway to a great degree. It's interesting. Always when I think of minimal crew, I think of things like the Thames barges that used to operate in the UK.
Yeah,
with
a man, a boy,
basically a captain and his dog, or captain and the cabin boy. Were able to operate, and transport 400 tons of goods very effectively on a vessel.
Yeah.
But it's interesting to me, you've got the autonomous control, but you've also got, if you've got wind integrated into the vessel, you also have autonomy in operation, because you don't have to go and bunker. You're
you don't have to go and buy fuel, because you put your sails up and you capture your fuel. But that's another thing that helps with increasing the efficiency of smaller vessels, because you're not having to carry the bunker fuel. Your carrying capacity, the volume of the hull that you can use for moving stuff rather than fuel, increases.
Can be increased too. Absolutely. No, it's interesting. When you start swapping these around, taking different perspectives. I mean, wind being a free energy source, changes a lot of the dynamics that we're used to in commercial shipping now.
It's an energy source that you're not going to be competing with everybody else for, because nobody else can use it. Any of the other energy sources that people propose for shipping, whether it's hydrogen or hydrogen in the form of ammonia, or electricity in battery form, or whatever it is, you still got to buy the primary energy from somebody else. And the cynics amongst you may think that that's why they're being pushed as the solution, because it keeps the current players there with something to sell. But wind power, offshore wind power, it's sort of free at the point of use, and nobody else can use it. So you're not competing with the rest of industry for it.
Yeah, no, it's. I mean, as you know, it's one of the sort of special points that we make quite regularly on that. And I think obviously on board generation of an alternative fuel using excess wind, takes that to another place as well, where it can be potentially in the future fully autonomous in its energy use. Which is an intriguing area. I'm not going to get into the alternative fuel debate at the moment, but no. But it is a really intriguing area, and I think one thing I've seen with the autonomous shipping side is it's also with the technology is assisting with wind propulsion. For example, the use of cameras for navigation is being championed by the autonomous shipping body, which
but
it's absolutely vital.
That also helps with the visibility issues that you sometimes get with some retrofit systems, because
indeed,
that is actually one of the more overlooked issues that sort of that people come up with as they're proposing their ideas. Is how you're actually going to see to steer the damn thing.
It's interesting. I think that will bleed into the design as well. But once, if that becomes standard, then designs can adapt to that standard as well, and maybe be larger, be more obstructionist, but providing even more power. Anyhow, I think we've gone right the way around. I think there we've gone from the fantastic materials your sails are made from, right the way through to a whole different view of how shipping could be working in the future. I'm going to bring it right back to you now. So I've got a few sort of short fire or quick fire Q&A. So I'd like just a single sentence, could be a single word, but a single sentence answer on these. The first one is, how did you personally get into wind propulsion? Obviously, it's about 30 or 40 years ago.
It was actually, well, it depends which part of wind propulsion. Wind propulsion, as in playing on boats, I grew up from yay high. I can't remember a time I wasn't playing with boats. In the must have been the mid-70s. My mother was one of the investors in Walker Wing Sales.
Right.
So she bought shares in that because she'd always had a interest and belief that shipping could be more efficient than it was. So I guess it's just always been. I've always assumed that it's the right answer, if you like. It's just always seemed natural. I've never understood why other people don't get it.
Right. Well, I'll probably tick that box with you as well. So
yes.
Yeah, it makes complete sense to me.
Yeah.
Now, okay, so other people don't get it. Why? What is after all these years of thinking about it, what is the main answer to the question of why don't people get it, or why haven't people got it over the last years?
I think part of it is this misguided belief that that markets always lead to efficiency, and because nobody else is doing it, it can't be efficient. Whereas actually markets always just make you run faster than the other person to get away from the bear. So you're not necessarily choosing the best solution, you're just choosing the solution that's incrementally better than the other person. So you tend not to take risks to develop something that may be a step change because it may be wrong. Whereas if you just keep ahead of the other guy, I don't know, maybe
the bear gets the other guy.
Yeah.
Right. So it's a little bit like the old adage, I think it was Ford or General Motors, where it was like, well, if you'd ask somebody in the 18th century to go, if they wanted to go faster, they'd ask for a faster horse, not an automobile.
Yeah.
You know. So yeah, no, that's I like the bear adage. Yeah, I'll have to remember that one. Now, tied to that, what's the most difficult problem you've had, sort of kind of breaking into this market or seeing this market for your sales and for wind propulsion, seeing that grow? What's the kind of biggest problem or difficulty or issue that you've seen outside of the perception? So I get the perception, but on a more, if you like, nuts and bolts level.
Well, I suppose in some ways we're not a project leader, and we're a equipment supplier. If you've got your ship and you want sales for it, we're actually already set up in such a way that we can provide that resource for you. The trouble is, not many people have actually got their ships built yet.
Right.
So we're an equipment supplier ready for a market which is only just coming into existence.
So the shout out from Wilf is, come on guys, get the ships in the water. Yeah. And fair enough. I think that's across the board.
Yeah.
But yeah, more ships, bigger market.
Yeah. Oh, it's potentially a massive market. Yeah, as an industry, just from a selfish perspective, it's a huge market. But I'd like a little share of, please.
Right. Okay. Well, we'll try and see what we can do. I've got two more questions for you. What is the most common misconception about wind propulsion that you see?
I think the perception that it's going to be unreliable, and the time, the people think, oh, you're not going to be able to know when you're going to get there. But if you look back, even going back to the records of logs from the 18th, 19th century, voyage times, with obviously a few exceptions when something went wrong, voyage times are actually remarkably predictable. And that's just using the knowledge that was widespread then. If you look at with the use of current weather routing and things, voyage times, their predictability isn't the issue that people think it is.
So yeah, no, I think you're absolutely right. I was looking back at the 1850s, and they had the logs there were, when they listed everything and people were following that, cut a third off the time as well. So it was faster and more reliable. Yeah, absolutely. And the final one is, okay, so, and I asked this of all the guests on Listening to the Wind. Things are moving. There's momentum in the sector. Are you recruiting?
Yes. We're essentially a manufacturing industry, and it's actually proving quite difficult to find suitably skilled, qualified people to help us with the manufacture, because we have a full backlog. So
right,
yes.
great. Well, I think that's the message that everyone wants to hear who's watching it. So I'm gonna back off for a minute or two and just give you a couple of minutes just to summarize, give us the audience a takeaway from today's presentation and from OneSails.
Well, I think as came up in the conversation just a couple of minutes ago, it's the fact that we're here, we're ready to manufacture the sails for your ship. Pretty much of any size of sail that we've seen planned, a soft sail that we've seen planned, we're set up to manufacture. So if you're building a sail with soft ship, so a ship with soft sails, get in touch.
Fantastic.
Yeah.
Fantastic.
And actually, likewise, if you're building something with a wing sail with a flexible surface, we've got the technology for that too. Excellent. We're an equipment supplier, and we're here.
There we go. Very, very succinct, to the point. I like it. Well, Wilf, I really appreciate you coming and taking some of your valuable time to talk to us today. And I'm sure, if the audience has any questions, you can drop Wilf a line. Also, of course, IWSA is always here to answer questions maybe on that bigger issues around wind assist and primary wind vessels. But without further ado, I'd like to say thank you very much, Wilf, and have a good rest of the week.
Yep, likewise, and thank you for speaking with me.
Thank you very much, and we'll be back soon with another episode of Listening to the Wind. Fair winds to you all. Thank you.